All right, this is 5.09, day number 3 of 4. We're going to add, subtract, and do scalar multiplication of vectors. Pretty easy. This will probably feel like what we did with matrices last semester. Very similar, if not the same. And we're being recorded, as always. All right, adding and subtracting. So all you do is simply add, subtract the corresponding components. Right. So for this one, we have vector f. This is vector g, and we are adding them. So the corresponding components will be x, and then 8 and 11. So you just do -4 plus 6 and 8 plus 11. That easy. That easy. So everyone, go ahead and do number 1, and I will give you 30 seconds to finish number 1. All right. In chat, everyone, what did you get for your answer? So we got the chevron brackets. Remember, these are not braces, Julia. Those are braces. We want chevron brackets, which are the like greater than, less than symbols. So we got 2 comma 19. Anybody else? 8 people in the live session. 2 people respond. What is that? 25% of people responded. 219. Everyone agree with 219? I think that's probably right. Yeah, you just add them up, set it up. So there's the setup. And so on your paper, you hopefully you're writing stuff down. And the more you write, it's more organized, the easier it's going to, the work is going to be. Even though this is pretty simple, right? So yep, component vector is 2 comma 19. All right, 30 seconds for the next one. Ready, go. All right, everybody in chat, go ahead and put what you got. So we got a couple answers here: 0, -15, and 14 comma 3. A lot of 0, -15s. So I'm going to say 0, -15 as well. So here's the setup. So a little tricky. This is just like matrices. When it's a negative, right? You have to distribute the negative into the vectors. That's why it's -7, -9. Little tricky, right? Hopefully not too tricky. Oh, you didn't see the minus sign? Okay, fair enough. Fair enough. All right. So there's my first step that I wrote. And then, this plus that is 0. -9 plus -6 is -15. All right. Let's try 2 more before we go on. All right. Let's do 1 minute for both, total for both of them. 1 minute.
Do we put both in chat or just one right now?
Not yet. I still have another 12 seconds left. All right. For the first one on the page, go ahead and write in chat what you get. Like we got -12 comma -11. -12, -11. All right. Looks like everyone's in agreement. Let's take a look. Yep. I agree. I agree. All right. So something I want to point out about this one, when you have subtraction of two vectors, you want to make them addition, and you want to distribute this negative to this vector. So this is important to do, and my guess is maybe a lot of you skip this step. I really think you shouldn't, because when problems get more complicated, it's better to show this step like I did. But I know a lot of you can probably say, oh, I can do -4 minus 8, which is -12, and -12 minus -1. Well, two negatives make a positive. So it's actually -12 plus 1 is -11. But I really want you to show, distribute this negative to this vector v as shown, and then make them addition. Your test, you will have to do that. I'm going to show you on the next page. There's a graphing method. So you have to make them addition all the time. Okay. All right. Number 4, what did all of you get? 5, -7. All right. I think looks like we're all in agreement. All right. Looks good. All right. Very straightforward. Okay, graphing. So on your test, on your quiz, we're going to add vectors graphically. Now I believe there's 2 methods. The one that's being described here is called the head to tail method, when you put the second vector starting at the end of the first vector. I believe that's called the head to tail method. On your test, it'll want you to basically solve, you want to add 2 vectors graphically by the head to tail method or the parallelogram method, which I will show you also. All right. So when you stick the second vector and you slide it over to the end of the first vector, where that second vector points to is the answer. And I'll show you what I mean in Desmos. So this said GeoGebra, but Desmos is what you really want to use. All right, let's take a look. Trying to share my screen. So many clicks. All right. Antonio, can you see my screen yet?
No, we can't. I'm kidding. We can.
Yeah. Okay. Good. All right. So the 2 vectors, and by the way, I'll share this link with people that are in chat right now at the end. But you can't graph a vector directly in Desmos or GeoGebra. There's some code that you have to do to make it work. And I already made this before class. I just Google like Desmos vectors, and I found one that was already pre-made, and then I modified it to work for what we're doing right now, the head to tail method and the parallelogram. So we have two vectors. Vector 1 is 3, -5, and the second vector is -2, -4. So here's the, oops. So vector 1, does everyone agree that that is the vector? And you want to have an arrow at the end of this. It's limitation by Desmos. I can't actually add it in. Everyone agree with this vector where I have it plotted? Yep. One person responded. Emily, thank you. All right. All right. The second vector is at -2, -4. Let me just turn that on. All right. So there's that vector. All right. So to do the head to tail method, we're going to slide that second vector to start at the end of that first vector. So we're going to slide this to start here. And I already created that. So vector 2 and a vector 1. So there we go. So all we did, we just slid this over here to start here, ends here. So wherever this ends, that is the answer. That is the sum of vector 1 plus vector 2. And that looks like that. So that dashed line is the answer. So we can see that looks like, so this would be 1, -9. Everyone agree with that? 1, -9? Okay. Very good. So that's called the head to tail method. The other method is called the parallelogram method. It's basically the same thing. So let me kind of back up here, turn off that. So all we're going to do is we're going to slide this to start at the end, just like the head to tail method. So that's going to look like this. And then we're also going to slide that first vector to start at the end of the second vector. So this, I'm guessing that's green, gets slid over here, and that's here. So see how it creates a parallelogram? Where these 2 points meet, well, is the answer. The addition of vector 1 plus vector 2. And you can see, well, it's the same. So they're basically the same. You're just drawing one extra line to create a parallelogram to see where the arrows meet. That's the only difference between head to tail and the parallelogram. Pretty straightforward. Yep. All right. So you'll have one of these on your test. You'll have to graph it, and you're going to have to graph the lines, the vectors, to show the addition of 2 vectors. Pretty simple. Okay, subtraction. So I talked about earlier on a previous page that whenever you have the subtraction of 2 vectors, you always want to make it into addition. So even though we're subtracting, distribute the negative to this vector and then make it the addition of two vectors, and then it's the exact same thing graphically. So the head to tail and the parallelogram, it has to be the sum of 2 vectors. So make sure you distribute that negative first before trying to graph it. And yeah, you just distribute that negative. So it becomes -2. This becomes +3. We did a couple examples at the beginning of this lesson. All right, scalar multiplication. Just like matrices, when you want to find like 9 times the vector of f, all you do is distribute your scalar into your vector. So you do 9 times -11 and 9 times -3. So let's look at that one together. So we're going to set it up with a 9 outside. And then all you do is distribute. And then you get your answer. Very straightforward, nothing tricky.
Can you go back super quick to the other side so I can take a screenshot?
Sure.
Okay, thank you.
Mm-hmm. All right, everyone try number 6. I'll give all of you 25 seconds. You hate the graphing tool. So what you can do is make sure you really go through those modules and the examples that actually have you graph, make sure you practice them. Because they do embed that stuff in the modules and probably the quizzes too. All right, what did all of you get for the second one on this page? 8 rad 2, comma negative 15 rad 2. Yeah, I agree with that. I agree. There's the setup. There's the answer. Pretty straightforward. All right, everyone try number 7 and 8. I will give you a total of 50 seconds for both of these. All right, first one on this page. What all of you get? 60, comma 144. All right, you're all probably right. Let's take a look. Here's the setup. Yep, I agree. 60, comma 144. All right, and the second one on this page. What did all of you get? 28, comma negative 14. Looks like everyone is putting that. Everyone's in agreement, it looks like. I don't see Sarah's response.
She said she was going to be away for a little bit. I don't know.
Okay.
Where she's going.
Okay. Fair enough. All right. I agree. Nicely done. All right, linear combination. So a linear combination is just doing both addition, subtraction, and multiplication in the same problem. Make sure that you follow the PEMDAS rules. Remember, parentheses, exponents, multiplication, division, addition, subtraction. That still applies. So if you have a scalar, make sure you multiply that first before doing addition or subtraction. All right, we got 4 problems. Let's take a look at the first one here. All right, so we're going to first set this up, and I usually skip writing the 2 in front. I usually just do the 2 times the vectors, but I did actually show it in this case, the full setup. And then from here, we do 2 times that first vector, and happens to be also 2 times second vector. So we want to show that until we get negative 4, 6 plus 6 comma 14. And then you just add the respective places, the x's with the x, the y's with the y's, to get the final answer of 2 comma 20. All right, everyone try number 10. I'll give all of you, I think 50 seconds should be enough for that problem. All right, what did everyone get for this problem? Oh, not done yet. All right, don't put the answer yet, everyone. Let's do this. I'm gonna do a little poll. When you finish, choose choice B. When you are done, choose B. If you're still working and you're still here, choose choice D as in dog. Some people are not here. Dun, dun, dun. All right, what did everyone get for this problem? Ones that are here. Negative 25 over 2 comma 14. Looks like we got a lot of those answers. Okay, looks like everyone's in agreement. Let's take a look. So we have the setup. Oh, I'm like, what did I do? There's another box. I was confused. Okay. Anyway, okay. No typo, just 2 boxes by mistake. All right. So there's the setup. Then we do the, multiplication of both vectors. That first looks kind of like almost like an X-wing fighter jet from Star Wars. That's what it reminds me of. And then the final answer, yep, negative 25 over 2, comma 14. And don't forget, on quizzes and tests, they want to see the negative in front of your fraction, not in the numerator, though it doesn't matter. But for it to grade correctly, it wants it in front. It doesn't know better.
One of these days, you should do like a slide that just has all of the things that the quizzes want that aren't necessary, but just have to happen because the quizzes are picky as heck.
That's a lot of work, Emily. It's a lot of work.
Wow, okay.
I'll tell you what. Do the practice problems in the modules and you'll discover how it wants the answer.
Yeah, I always do them. It's just
You just want the easy way, right? You want it easy for you and hard for me. I don't like your plan.
like
I don't like it. Don't like your
I
plan.
like it.
I don't. I'm totally against it. You're outvoted.
No, I think most people would probably agree with me though.
I'm like the president. I veto it. So nope, doesn't work.
Wow. Wow. Wow.
I am true president. I am also vetoing this bill.
I'm offended.
Won't be the first or last time. That I can promise you.
No, yeah, no, it.
All right, number 11 and 12. And I'm not saying offended by me, I'm saying by other people in general. All right, let's do.
Oh no,
We'll do 2 minutes.
this is not the first or last time I've been offended by you. So
Ooh. I would suggest filing a complaint and dropping it in the nearest trash can. All right, 2 minutes, everyone.
Thank you for not making the second one harder than it had to be.
You're welcome. All right. Everyone put the answer to the first one. Let's see what we get. 17, comma. Uh-oh. Oh, Emily. Like we got some different answers here. We got 17, -3, 17, -4, 17, -5. Oof. Looks like the 17 -5s have a majority, though.
I agree with -5s. I see my mistake now.
Yeah. So if you didn't get the right answer, ask yourself, did I show enough work? As easy these problems are, skipping steps is a great way to miss them.
In my world, -3 times -1 is 5.
Sometimes in mine as well.
I'm just a complete idiot and added 3 and 1 instead of multiplying. Because for some reason I have absolutely no brain.
It's early and the screen's a little blurry. Thank you, Neuro.
I have 1 brain cell and it's currently occupied by a song stuck in my head. So
Okay. Let's see what the answer is. Well, that can't be the answer.
You're showing it for the second one.
Oh no.
Which, unless I'm messed up, is also horribly wrong.
I know. I'm pretty sure that first one is well, it's the number 12. My answer is wrong. I have to double check. I think I made an oopsie. All right, -17, -5. Yep. So looks like most people got it correct. Antonio fixes mistake. The others fix their mistake, I hope. No, so that second answer I showed, at quick glance, I can tell you that it is definitely not correct, and that's because we shouldn't have any fractions for the answer. Antonio mentioned earlier, thank you for making this number 12 easier than it could have been, right? That's because when you do a half times, this is vector h, half of it, 2 even numbers, it still stays an integer. It doesn't become a rational number. And then, this integer here times 2 integers here and here also keep it as just integers. So when you have integers, plus or minus integers, you shouldn't have fractions. So it's pretty clear when I uncovered the answer to number 12 that I definitely mistyped it. So go ahead and
the answer from the last slide from number.
It is. Yeah, that's what I do. I usually just like copy and paste the formatting from previous slides, and obviously I didn't change the work for it. So, yep, I see what I did. Go ahead and chat. Go ahead and write the answer, please.
The answer gave Star Wars vibes, so the Force was not with you.
12-7. Retyping my work. The entire work for that problem is it's just copied from the previous page. I never updated it. So 12,7, I do agree with that. Let me go ahead and redo that work. I'm even going to show you what is underneath those black boxes because it's not good. All right. All right, so we have -2g. I'm just going to go ahead and set it up. We have -2. Oops. Distribute. And all done. All right, nice job, everyone. Before we stop the recording, any questions on today's lesson? Other than why isn't this, like when does it get hard, right? It's, today was an easy one. It's over already. The pain, the misery is over, and we did it in 43 minutes. Actually less. Very quick. It must be Friday. Yes.
I
Well,
wish Neuro had a
guys,
feature where you could put boxes below your typing, so I could have covered it all without covering your typing.
Right. All right, guys. Thanks for coming. And as always, I hope you learned something.